So this is Unit 3, Lesson 1, over arithmetic sequences. So an arithmetic sequence is just a list of numbers in which the difference between any two consecutive terms is constant. So another way to say this is just if you have a list of numbers, then you are adding or subtracting the same number each time. So this is a lot like a linear function. Now, the common difference is just going to be the difference between any two consecutive terms. So this is the number that you are adding or subtracting each time. So when we want to determine whether a sequence is arithmetic, we just want to see if we are adding or subtracting the same number every single time. So looking at number 1, 1 to 5 we're adding 4, 5 to 9 we're adding 4, and then 9 to 13 we're adding 4. So I know this is arithmetic, and my common difference is 4. For number 2, 1 to 3 add 2, 3 to 5 add 2, 5 to 8 add 3. So no, because I don't have a common difference, this is not arithmetic. Okay, number 3, 8 to 6 subtract 2, 6 to 4 we're subtracting 2, 4 to 2 we're subtracting 2. So yes, this is arithmetic, and my D, since I'm subtracting, is going to be negative 2. So pause the video here and work 4 through 6 on your own. Okay, number 4, negative 5 to negative 8, subtracting 3. So yes, D equals negative 3. Number 5, I already know no. And then number 6. Okay, if I want to find the next 3 terms in an arithmetic sequence, we're using what's called a recursive formula. You use previous terms to find the next ones. So this is something that you've probably been doing in elementary school. They would give you a pattern, and then you would find that pattern and then use that pattern to find the next couple terms. So for this one, they already told us it's arithmetic, so all I need to do is find the common difference. I can look at any 2 terms. So from 9 to 13, I know I'm adding 4. So I'm just going to take my previous term and add 4. So 21 plus 4 is 25. 25 plus 4 is 29. And 29 plus 4 is 33. Oops. All right, go ahead and pause the video and do 8 and 9 on your own. All right, so number 8, we're subtracting 3. Negative 7, negative 10, negative 13. And then number 9, we're adding 6. So we'll have 16, 22, 28. All right, now we can also use what's called an explicit formula. And these are more effective because you can find any term in a sequence using this formula. So one quick thing, A represents your term, and then the number that is next to it, the subscript, represents the position of your term. So if I want to find the nth term, I'm going to have a sub n equals. We're going to take our common difference and multiply it by n minus 1, and then add our first term. And so d we already know is our common difference. And then a sub 1, when we think about that, the subscript 1 means we're talking about our term in the first position, so our first term. All right, so number 10. First thing we want to do, find our common difference. So each time we are adding 6. Okay, and then we want to say our first term is 7. So then we're just going to plug this in. So to write the rule, we'll have a sub n equals, replace d with 6 times n minus 1, replace a sub 1 with 7. And then we are just going to simplify this using what we learned in the first quarter. So distribute our 6. And then combine our like terms. So this is our rule, or our formula for the sequence. And then to find a sub 19 right here, I'm just plugging in 19 for n. So 6 times 19 plus 1. So 6 times 19. Oh. Let me find my calculator. Times 19 plus 1 is 115. So my 19th term is 115. Okay, moving on to number 11. We want to find difference and first term. So difference, we are subtracting 4 each time, so our common difference is negative 4, and our first term is 30. So when we plug this into our formula, we will get a formula that looks like this, and then we simplify. Okay, so this is our rule, and then we're going to plug in 19. So negative 4 times 19 plus 34 gives me negative 42. Okay, go ahead and pause the video and then do 12 through 15 on your own. last problems are application problems. So number 16, you visit the Grand Canyon and drop a penny off the edge of the cliff. The distance the penny will fall is 16 feet for the first second, 48 feet the next second, 80 feet the third second, and so on. So our sequence here is 16, 48, 80, and so on. So to write a formula, we follow the same steps. So we find D and A sub 1. So first term is 16. We're adding 32 each time, so D is 32. So A sub n equals 32 times n minus 1 plus 16. Simplify. And then if they want to find how far it will have traveled after 6 seconds, we're going to substitute 6 for n. So 32 times 6 minus 16 is 176. So it will have fallen 176 feet after 6 seconds. All right, last one. The total bank loan for Sarah's new car is $15,265. The bank automatically withdraws $295.80 each month to pay off the car. So for this one, instead of using this arithmetic sequence, we're actually going to go back to what we know about linear functions. So we're going to use slope intercept. So we know that we start with this much money for our loan. And then each month we're taking away $295.80. So this is going to be our formula. And then to find our balance after 2 years, we're going to plug in 24 months. So negative 295.8 times 24 plus 15,265. So negative 295.8 times 24 plus 15,265. So the balance of the loan after 2 years is $8,165.80.